Hi, hope you are doing great. In this video, I'm going to talk about Redux architecture with SwiftUI. And actually, the first time I deal with Redux was while I was trying to learn React and React Native. And I thought about it can be implemented in SwiftUI as well. And Redux is about predictable state container for JavaScript apps, which make your app state more predictable, because actually it's moving your state to a central location, which will help us to have a single source of truth for the inner application. Redux is a state management system. The main items in this architecture is view, action, reducer, store and state, and for sure dispatcher. So view, it's related to design itself, like any design pattern and so on. And action, this action actually when we have any action like add, for example, add user, add to do, or whatever. So actions mainly contains the data that we have to process to meet its app state, and also a reference to a reducer, which is basically a function, a pure function actually. And when we talk about reducer, we will talk about why it should be a pure function later on. But also there is a dispatcher, and dispatcher manage all the data flow in the application. Actually, it's not has a real intelligence or function. It just receive an action and send it to the store for processing. And middleware here, it's a layer between action and reducer, because as I mentioned before, reducer should be a pure function. And if we talk about pure function, what is it? It's returns the same result if the same argument are passed, depending solely on arguments passed into them, and don't produce side effects such as API request and input-output operations, which means that reducers can't handle directly with API service or any side effects. We need to add another layer between this to apply over this stuff. So middleware here allow us to enhance the store by hooking into an intercepting action before it's reached to the reducer. And why pure functions are great? Because for our purpose, the most important feature of the pure function is that it's predictable. If you have a function that takes in our state and an action that occurs, the function should, if it's pure, return the exact same result every single time, which go with Redux principles. Now we have an overview for Redux architecture, and know that it's useful to have a single source of truth for the inner application, and it's trying to offer a predictable statement management. Let's take a look at what we will implement in this video. This is a list which is trying to fetching data from API. We will handle this by Redux architecture, and also this demo has an adding user form, but actually we will talk only about fetching because adding will follow the same principle as well. So let's get started. And because this video will focus on only Redux, I already added some models, view, and service, because it's here we only call or trying to fetching the users and so on. And regarding to the list, it's related to design, nothing more, and I added a static user here. So what we will need to start, we with, we have a view, we need to add the actions. So let's go and create actions. Call that user action. And when we think about what exactly the action is needing in the listing screen, we will find that we will need a case for fetching, and another one for telling us or inform us that fetching is completed, and one inform us if we face or any error or something went wrong or stuff like that. So user action will be handled like it will be enum which has these three cases. And when the fetch completed, we will receive the users, right? And also want to handle error, inform us that there's error. Okay, this is user action. We will need another action which because the application itself might has user action and cart action or whatever the application. It's not only user actions. So here we will create app action. And app action will only has the user action, nothing more here. So now we have view, action, also we need to handle the state. So let's create another, directly call it state. And we will create one for user state. User state will be struct which actually contain the users which we gonna receive. Is fetching, which will inform us if it's still fetching or not, and another one for inform us fetching error. Let's call it only fetch error. We will need another one for app state. It will be also another struct. and for now it will only have the user state. Awesome. So now we have the state, view, action. We need to implement the reducers, and as I mentioned before, reducers is a pure functions, so it will be simply functions. Let's create another folder here and call it reducers. Let's start with user reducer. It will be function, which gonna actually, let's do it here. Reducer will take two things, state and action. So let's map it here. It will be the state, and it will return nothing. We add in and out here because actually this is immutable. This signature is immutable, and we will need to change the state. So we will switch to the action because, as you remember, user action had the three cases. We will need to handle this. So after switching and add all the cases, for fetching we will need to handle or update the state. So for fetch, the state dot fetch error basically will be nil because there's nothing happened yet. And for state dot as fetching, this will be true. For fetch complete, we will actually apply the same. Fetching error should be nil, and but is fetching will be false because actually the fetching operation is done. And state.users, we will get the users here. Okay, for fetching error we will do the same thing, but we will handle the error. So state dot is fetching will be false, but we will need to, because in network, if we go to where's the service, yes, exactly, there's different errors, we will need to handle it. So let's get back, and if we switch to the error, for invalid URL, for example, we can assign the error to be something invalid URL. Please check it again, and so on. So let's do it like default for now. Make state something went wrong. Okay, this is it's a user reducer. We will need another reducer for the application itself, so let's do it. Let's go and name it app reducer. And it will be the same, a function, which is take state and action. Put it out reducer, and it will handle the state. Also action, which is app action, and the same, return void. Actually, here we only have as user, so let's call the user reducer, and the action will be action. Also, we can add a reducer as a type. We can add a type alias for reducer, so we can do it type alias reducer, which handle action, state and action. And out state and action, and return void. Okay, it's back. Now we have the reducer. The next step, we will need to implement a middleware, because here we are fetching API, fetching data, so it's some side effect, and we can't do it in the reducer. Actually, we can programmatically we can add this in the reducer, but it will go against the Redux principle. So we're gonna add the middleware as I mentioned before. So let's add here middleware, and call it user middleware. Middleware can be function, which we will take the service, because yes, as you see here, it will deal with API service. User services, and this is what return any publisher. Let's first import compile. Any publisher for action and never. But actually we can make a type alias for this to be a middleware. So type alias middleware, for state and action, which will take state, action, and return this. And now here we can simply use alias, and here the state will be the app state and action will be the app action. This will return state, app state and app action as well. And here we will need to switch the action. And for now, what actually have is only the user, which is the listing screen. And for listing screen, we need to consume the get users in this service. So we will call it like this: return service dot get user and here in the constant we already have the API URL, and then we need to subscribe to the main queue. And need to map the app action to fetch complete. And here we will inform that the operation is already, or the fetching data is already completed, and the user will, we will receive the users. Then we also need to handle the errors, so we will catch it through the catch. We will have this error, which is network, type of network error. We will return just of app action. Here we will need to switch the error as well, the same way we did before for error. Let's do it for invalid URL, and we need to return app action.user fetch error, and the error we will call it network error.invalid, and so on. Let me just speed the coding here. Now we need to erase to any publisher, and also make it to handle the fetch. No need to handle it. Now we can add default rect default break, and after that you can simply return empty. Okay, now the middleware is ready. And if we back to, so we will need to handle the store. Let's add another directory. Let's call it store, and here we can add App Store. Let's open it in another tab. Okay, store can be a class. And we're gonna handle state, action, and implement observable object. And as we see here from the diagram, we will need to have access to the state, and also we will need to have a variable for middleware and also reducer. So, and dispatch this will be a function. So let's start and declare the state, and it will be published. And we just need the store, the only place which is modify the state. So we need to make it private for set. Then declare the middleware. And because the application itself has multiple middleware, so it will be array of middlewares. Then let's move to the reducer. And yeah, let's start with init. Which is basically initial state. Also reducer. And middleware. Middlewares, which is array. The text will be the same. Reducer. And self dot middleware is equal middlewares. After that, we will go to define the dispatch function. Dispatch function, which will receive an action. And call the reducer, which will handle the state and action. Also, we need to dispatch all the middlewares. So we will go for every single middleware in middlewares and just make sure that guardlet the middleware. For the state and action, otherwise we will return or break. If we make sure that the middleware is already there, then we will go to every single middleware and receive on the main queue. And also sync receive a value for dispatch. And the last thing it will be to store. We will need to define any cancelable set. So we will here define, we'll call it, for example, middleware cancelable. We need to import confine here. And here we will need to add escaping. And yes, now we have approximately all the components. We have view, actions, middleware, reducer, store, and state. The next step, we will need to go to content view, and here in the content view we gonna define the store, and actually we can do it to go to the store and add a type alias as well for the app store. And instead of calling store, state, and action, we can type alias and call it app store, which is mapped to this one. So yeah, let's proceed. Okay, let's go. Yeah, here it's will app state and app action. And instead of just type it every time we need the app store, we simply can call app store. So let's proceed with this. We can call it app store. here the initial value will be init for the user, and actually the user will be the user state. Let's minimize this, no more courses. And reducer will be a producer. We don't need this. And middleware, it will be an array of middlewares. For now, we only have one middleware, which is the user middleware. So let's define it and this, and it will be user service. Cool. And here we simply can call the user view and bind it through the environment object. The store. Cool. Everything is ready now. It's ready for the user list view. We can go to this, and user list view can bind itself through environment object for the store, or basically app store. So let's define environment object for the store, and here we can dispatch the fetching action through self.store.dispatch, and what we need to dispatch here is the user action with .fetch. And instead of users, which is this variable, no need for this anymore, we can directly call self.store.state.users.user.users. So yeah, let's try to run and see what's the result. So yeah, now we receive successfully the data from endpoint and using Redux architecture. So congratulations. Yeah, just to recap or wrap up what exactly the main points we talked about. This point is that Redux architecture is useful to have a single source of truth, which will make the application more predictable. Also, as we see, reducers should be a pure function, and now we actually know why the pure function are great. And this is because if we have a function that takes an outer state and an action that occurs, the function should return the exact same result every single time, which go with Redux architecture. Also, if we have a side effect or input-output operations or stuff like that, we will need to add a middleware, and this will enhance the store by hooking into an intercepting action before they reach any reducers. And yeah, that's all. Thanks for watching and have an awesome day.